Hello, I am Professor John Kelly, and this is the Weber Auto YouTube channel. Today we are going to be looking at the 4th generation Prius lithium-ion battery. Now the 4th generation Prius actually has 3 different battery options. There's the traditional nickel metal hydride battery that's been around since the very 1st generation Prius. And then starting in 2016 with the 4th generation Prius, there's an optional lithium-ion battery. Now the nickel metal hydride batteries had a battery voltage of 201.6 volts. The lithium-ion battery here has a battery voltage of 207.2 volts. So they're very close to each other as far as voltages, which makes having one or the other an easy transition on this vehicle. There are still differences in how the battery is charged and maintained and balanced and everything else. But today we are going to disassemble this 207.2 volt lithium-ion battery and show you what's inside, show you what is serviceable. There's a lot of serviceable components inside of this, and what has improved over the nickel metal hydride battery of previous models. This battery is found under the back seat lower cushion on the 4th generation Prius. If you have a lithium-ion battery or a nickel metal hydride battery in a regular Prius or the Prius Eco, which comes with the lithium-ion battery, that battery is under the back seat rear cushion. If you have the Prius Prime or Prius plug-in outside the United States, then the lithium-ion battery is in the rear hatch trunk area rather than under the back seat cushion. So as with any high voltage battery, we want to use our personal protective equipment. I've got my high voltage gloves here. I've already tested for leaks. Now in the vehicle, while it's still inside the vehicle, this cover right here is still on the battery. And we've got the high voltage cables, the 2 high voltage cables that leave the battery and go up front to the inverter converter assembly underneath the hood that connect underneath this cover. So we have to remove this cover to begin with. So we've got just some 10 millimeter bolts and nuts. On the front of the battery right here, we have the service plug grip, as it's called. Now on previous Priuses, the service plug grip was a rather large device, and that's because it contained a fuse, a high amperage fuse, like a 125 amp fuse, inside of the service grip. This battery does not have a fuse in the service grip, so we are just going to pull down and then rock it out. These gloves make it harder to do. Come on. I can't quite rock it forward with my high voltage gloves here, so let me rock it forward with a insulated screwdriver here. So now I've got it rocked forward. Now I can just pull it straight out. Now as you can see, the 4th generation Prius service grip is just a little tiny piece compared to the 2nd generation and 3rd generation service grips. So just this little tiny service grip. So we'll set that out of the way. Oh, actually no, we don't want to set it out of the way. We need the service grip to disconnect this little orange plastic tab here. And this plastic tab just has a hole in it. We're going to come in with the tab on the top of the service grip, turn it counterclockwise while holding the bottom part from rotating. And then we can just lift out the little piece here. I've forgotten the name of this little piece, but it's there just to remind you that there are high voltage components underneath this cover. Alright, so now if we lift off the cover here, By the way, this is called the number 1 high voltage battery cover panel right hand. So now we can see inside the battery area here on the passenger side of the vehicle. We would have the 2 heavy orange wires come in and connect positive right here and negative right there and go up to the converter assembly. Right here we have our battery junction block with our positive and negative contactors, our pre-charge contactor, our pre-charge resistor, and we will get to those here in a few minutes and show you what is serviceable in there. But now let's take off this upper cover. So there's a warning label right here warning us that there's high voltage inside and to be careful, and it's to be serviced only by qualified technicians. It tells qualified technicians, for servicing or replacing this unit, follow the repair manual. After replacing this unit, perform battery diagnostic to correct ECU data. So there may be some programming, firmware, software updates required. Then there's also a couple of phone numbers here for battery recycling information. And then over here there's another battery label. It says battery assembly high voltage, and get this, it's a 0.75 kilowatt hour battery. So not even 1 kilowatt hour. So it's a fairly small battery. In other words, you're not going to drive very far in electric vehicle mode. For my experience, you typically get around 3.5 miles per kilowatt hour. So at 3/4 of that, maybe 2.5, 2 3/4 miles, which is more than the first, second, and third generation Priuses could do. All right, now we've got some bolts and nuts in the front here we need to disconnect. An interesting thing I noticed on these nuts and bolts is every nut and bolt in the entire battery assembly is the same except for 2 bolts. So it would be hard to mix up bolts when you go back together. All right, let's turn this back around. By the way, this battery is not very heavy compared to the previous batteries. I'm not very strong, and I can lift this battery. There's a warning in the service information when you take the battery out of the vehicle not to tilt it more than 80 degrees. I assume because of electrolyte spillage issues. All right, now we've got all the bolts out of the number 1 hybrid battery cover subassembly. Official naming convention there. We can lift up and slide forward and take off the upper cover here. I want you to notice on the inside there are foam seals to keep the air flowing for cooling where it should go. This is an air-cooled battery. Now, being an air-cooled battery, there's a cooling fan that connects right here and will pull air in from the passenger compartment right in from a vent right in front of the right front corner of the rear passenger seat and blow it into this housing here. That'll split it into 2 separate housings where it'll blow air up through the center of these 2 battery stacks. We have 2 separate battery stacks here of 103.6 volts each. There are 28 3.7 volt lithium-ion battery cells in each stack. So the air will go in under the stack, come up through the stack, get sealed against that upper cover, and then pushed out over here through what they call the number 1 HV battery hose, or an outlet duct. And so we can take this duct off. There's just a little clip here holding it on, and it comes right off. So we'll set that off to the side. All right, so let's look a little more closely here at what parts we have. We've got the high voltage battery junction block over here on the passenger side with our contactors and pre-charge contactors and the current sensor to measure how much DC current is leaving this battery. This is a DC battery. Then we have one battery stack here of 28 3.7 volt lithium ion battery cells. These are in a welded together housing. You can remove the entire stack, but you can't separate individual battery cells. And then we have another 28 3.7 volt lithium ion battery cell stack here on the front. And these are numbered as far as connector ends for each side of the battery cells, 1, 2, 3, and 4, right in the plastic housing there. Now, we've got a negative terminal right here. That's the negative terminal overall of the entire battery, and it comes right over to the hybrid battery junction block where it connects through the negative contactor up through the negative high voltage cable to the inverter converter. Then on the other side of that same battery stack, we have a positive terminal. So we've got, if we measure the voltage on this positive terminal here, it would measure around 103 volts. And its positive terminal then has this wire that comes over and connects to the negative terminal of the other battery stack. So we have 103.6 volts plus another 103.6. They're put in series with each other, just like two flashlight batteries. And then the overall battery positive terminal for the two battery stacks put in series with each other is right here. And it has a wire that connects to the fuse that used to be inside of the service plug grip. But now it's just down in a separate fuse holder down below. And then that positive voltage wire comes over here to our service disconnect right here, and when it finally is connected, then it comes over and applies full system voltage to this side of the hybrid battery junction block. And then through the positive contactor we connect to this terminal here, which is the high voltage cable that goes up front to the inverter converter assembly. Now over here on the driver's side of the battery, we have what is called the number 1 hybrid battery protector. It's, for some reason, there's I don't know if it's a heat shield or an electrolyte shield, but the battery ECU, the battery computer, is underneath this plastic cover right here. And that goes all the way down to the bottom of the battery tray, is what this bottom part is called, and has a little seal around the bottom of that. We have an electrical connection right here that connects 12 volt power and ground. And remember, the 12 volt system, the low voltage system, is what controls our contactors. It turns them on, turns them off. We have two different CAN lines, a CAN 1 and a CAN 2. And then we have fan control outputs from the battery ECU through the main harness over to the fan itself. And we'll look at that fan a little bit later. So that fan is controlled by the computer here in the driver's side of the battery. Now we have 1, 2, 3, 4, 5, 6 additional harnesses that are connected to the batteries. So we have 4 of them, which are the 2 outside ones on each battery stack. They have individual wires that go to each battery cell, and you can look at the electrical connection. If we took off one of these covers here, for example, let's take this one off right here. So as you can see, down inside here we have little studs coming up for the positive and negative posts of the battery cells. and then every other one of these has one of these wires hooked to it that's a voltage sense wire. So the battery ECU is watching the voltage of each individual cell, and then it looks for a difference in the state of charge. Now, lithium-ion batteries don't like to have a difference in state of charge when they're put in series like this. They have to be balanced. And so there's a special balancing procedure if you ever have to replace one of these battery stacks. Depending on the difference in the state of charge from the one cell or the highest cell to the lowest cell, you may have to let this battery sit for, well, depending on the difference in the state of charge, up to 109 hours. 4.5 days for it to balance all the battery cells by itself. And that's worst case scenario. I think the earliest one, or the smallest time one, of course, would be 0 if there is no state of charge difference, but 13 hours I think was the lowest one I read about in the service manual. If you were off by, it seems like 3%, 6%, something like that. I'll have to look and tell you. All right, so we have 4 sets of wires that come in and measure the battery voltage on each individual cell. On this harness right here, on the first battery stack, it's every other stud, every other cell. And then on the second harness on that first battery stack, those wires connect to the other cell. So they're looking at the overall difference in voltage from one cell to the next. All right, let me take off this other cover right here so we can get to both sides of the same battery cell just to make some, just to take some measurements. All right, with both covers removed, you can see the full set of studs straight across for each 3.7 volt battery cell. Now, let's take some voltage measurements. We put our voltmeter on DC volts, and let's check it on another voltage source just to make sure our meter leads are good. I've got a 12 volt battery just to ensure our leads are good and our meter is working like it should. 12.77 volts, so we're in good shape. Okay, I'm just going to set this meter right here. So from positive to negative across the same battery cell, and I get 3.65 volts right there. If I go from the negative, let's see, no, that's the positive, all the way over here to the negative, we should get pretty close to the 103 volts. I'm getting 102.2, so it's down just a little bit from the 103.6 volts that it would normally be. So these voltage sense lines take a measurement of each battery cell voltage. These are all in series with each other. These have little bus bars down inside, as you can see, the little metal bus bars, just like the nickel metal hydride ones did. They had copper ones. Hopefully we won't have connection problems with these in the future. Time will tell. This is a brand new battery out of our brand new Prius Eco that we bought, and so it has 35 miles on it, I believe. But anyway, it is a possibility. Okay, for continued disassembly, let's get this multimeter out of the way. Let's get the battery junction block out of here and disconnect all our high voltage wires here. So let's take these two batteries out of series with each other. So I'll unplug the front battery stack from the rear battery stack, and now we don't have 204 volts or so with the two put together. We only have the 102 per stack. And then let's disconnect some wires here at the service plug. So there's one of the service plug wires. The other one comes over here to the positive battery post. There we go. So we've got it disconnected. There's a harness support bracket right here that I can open up and get our service plug grip connector out of the way. So here's our service plug grip connector. Our service plug plugs into there. So we'll set it off to the side. And then we have the negative battery cable coming into the high voltage junction block. And then we've got a little white wire right here, our little white connector with 4 wires that is our current sensor. So in the high voltage junction block area here, we have a current sensor that is built in to the junction block. So now we can take the 4 nuts off that hold the high voltage battery junction block in place. Maybe. I'll have to break it loose. We'll use the coated tools and the insulated tools as much as we can rather than the conductive ones, although everything is disconnected here on the junction block. Alright, so that's all disconnected. Now we can just reach down and lift out. Looks like that nut just a little bit more. There we go. Lift out the high voltage battery junction block assembly. So we've got the negative contactor, positive contactor. The pre-charge contactor is under this orange bracket here. The pre-charge resistor right there. Our current sensor is underneath the positive battery connection from the battery itself, and it measures the current that goes out and up to the inverter converter assembly, and of course the current that comes back in, because that is a two-way setup there. Okay, then this battery, or the junction block tray, can come out next. So that just slides forward and off it comes, and our junction block fits down inside of there. Now we can see the intake duct where it splits into 2 inlets, one for underneath each battery stack. This has a little plastic clip that holds it in place also. Right there, and then that just pulls out. It has a temperature sensor, an inlet temperature sensor, that has 2 little squeeze tab locks on the inside of it. Two little squeeze tabs right there. And we'll set our inlet out of the way. And then right here we have our fuse, our high voltage fuse. So we've got one more wire, the positive terminal from the battery stack number 2, that's connected to it. So I can unplug it, get it out of the way. And then there's just a little tiny clip that holds that fuse in place. And up it pulls. So our 125 amp fuse is inside of this connection here. If I grab just a little screwdriver and push up on the white tabs on each side, out it comes. And you can see right in there a 125 amp fuse. Let's see, does it have any other rating on it? I don't see another rating. It just says 125 amp. So I'll just put that cover back on there. I'm sure this is purchased as one assembly if you were to have a blown fuse. And why would you have a blown fuse? Well, maybe one of the high voltage wires that goes from the battery up to the converter assembly got shorted to the body of the vehicle in an automobile accident, or somebody lifting a hoist in the wrong location, and would possibly cause that to short out, which could cause this fuse to blow. All right, now let's concentrate on the driver's side of the battery. There is a shield, a metal shield that covers the driver's side of the battery. So we'll take that shield off. It also has a little pinch tab wire harness connection right there for our interface between the battery and the rest of the vehicle harness. Come on. There's one. There's the other one. Okay, so just a little shield here on the outside edge. And then the plastic cover that holds the ECU inside has 3 little nuts that hold it in place. So take those nuts off. Notice we're reaching pretty deep down inside the battery, so it's a really good idea to have some good coated, insulated tools for high voltage work. Now, as we lift this cover off of here, there's a couple little plastic tabs that lock it in place. So I've got to release those. Okay, there's one. And there's one more on the inside here. Here we go. So now our cover comes up. I've got 2 nuts that are free though, sitting there. So let me get those out of the way with magnet tool. And then we've got the series high voltage cable for battery stack number 2 right here that has little clip connections to hold it to this cover. Get that out of the way. And now you can see right here the battery ECU assembly, as they call it. Now it has 4 orange connectors, which are the orange connectors 1, 2, 3, and 4 to measure the individual cell voltages right there. So we will disconnect those. Try not to pull on the wires themselves. We want to try to pry out or push on the harness connector to get those out of there. We don't want to break any wires at the connector. Now we've got two white electrical connectors here next. One of those is, of course, an interface with the outside of the battery, but the other one goes to temperature sensors and the current sensor. So each battery stack, as you see here, has 3 temperature sensors. They're called thermistor, and they start with 0. Thermistor 0, 1, 2, and then thermistor 3, 4, and 5 over here. And then there's one more sensor on the first one that is our inlet air temperature sensor from the fan. And then the additional wire on this side is, or 4 wires, are for the current sensor at the high voltage battery junction block. So now let's get that battery ECU unbolted. Oh, we've got the the 2 connectors to undo. So there's one, and the other one. All right, I'm just going to break loose the 3 nuts that are holding that down, and bring in my insulated tool. Okay, and we'll lift out the battery ECU, tip the 3 nuts off of it. There's a notice, there's a label here on the front of the battery ECU, and it reads, to hold the learning value of the battery ECU, replace only with new parts or remanufactured. Do not replace the battery computer and the engine computer at the same time. Apparently they need to communicate with each other with stored data to make sure that they're synchronized and the security system is working as it should to allow the vehicle to turn on and move down the road, I believe. All right, then we've got the bottom of this plastic ECU shield just sitting in the bottom of the battery tray. I want you to notice there's a foam-like seal on the bottom of it. I wonder if that shield is just for temperature reasons. These batteries get pretty hot when they're discharging and when they're charging, and maybe to prevent the battery ECU from overheating, they keep it inside of that plastic housing. I couldn't find anything that explained why that housing was there in the service information. Okay, now we're just about disassembled. This battery stack is held down with 4 bolts, and this one's held down with 4 bolts. We've got a couple of clips over here that hold all these harnesses to the case itself. So let me undo the clips. There's one. There's the other one. And now we just come down and loosen all 4 of these bolts, staying away from those battery terminals. Let me take these out while I'm here. All right, we'll get those nuts out of there so they don't fall in the wrong location and cause a short circuit somewhere. And we'll go over here on the other side and do the same thing. All right, so let's break loose the hold down bolt. Nut, I mean, it's not a bolt. There's a stud hooked to the bottom of the battery tray that these nuts go on. Oh, one thing before we remove the battery tray that I want to show you. The nickel metal hydride battery modules that we've seen. I've got a previous video on the 3rd generation Toyota Prius battery. These are 6 1.2 volt battery cells, nickel metal hydride, in series with each other, so 7.2 volts. I've got 2 of them hooked positive to negative here, so they're in series, which gives us 14.4 volts. You can, on this same car, instead of lithium-ion batteries, you can get nickel metal hydride, but it makes about a 4 mile per gallon difference to have the lithium-ion battery. So I don't know why you would want, it costs more, but I don't know why you would want to go with the nickel metal hydride. But check this out. If I lay the nickel metal hydride batteries across the tray here, they fit in the same spot as these 2 battery stacks of lithium-ion batteries. There are 28 of these that would be in a row for the 201.6 volt battery, which would extend it clear down to about right here, but it still fits in the same housing. Now, I don't have a Prius with a 4th generation Prius with a nickel metal hydride battery in, but I'm pretty sure it would be the same looking battery tray, and you'd open it up and it'd just be 28 of these in a row instead of the 2 stacks of lithium-ion batteries. Okay, well, let's take out the last 4 nuts holding the batteries in place, the battery stacks in place. We'll get those nuts out of there. Get our tools out of the way. And now we have 2 individual battery stacks that will just lift out. So let me pull this battery back here so we can see what's going on. There's a metal bracket here that holds, that's welded together, that holds all of these battery cells together. Let's make sure we've got our harnesses disconnected. Yes, we do. So I'm just going to come in and grab that tray, grab this tray, lift it straight up and out. So there is 1 battery stack, and this other one is the same thing. And we'll just set it off to the side here. Get our battery tray out of the road. Now, as you can see, 2 individual battery stacks, lithium-ion. If I get this one back out of the way, let's just look at this first one here. I'll tilt it a little better so you can see the nuts, the studs, the bus bars that connect those together, the individual wires for the battery voltage sensing going on there. And then if I can't tip it over because we're not supposed to exceed the 80-degree angle, but there's, as you can see, we've got plastic covers on the side to protect the battery, or protect you from touching the battery housing, the battery cells themselves. I know on some lithium-ion batteries they tell you not to touch the sides of the batteries because some of the sides are conductive. I don't know if that's the case here on these. I guess I can put a multimeter on it and see. I believe these are there to block the air from coming out the side of the batteries and force them to come up the front or the top of the batteries and go out through that ducting on the side. Let me grab my multimeter and let's see if those sides are conductive. Okay, so we'll pick a cell, go right here, nothing, nothing. Let me get a little deeper probe going here. Ooh, 2.4 volts, sure enough. So yes, the sides of the cells are conductive. So it's a good thing they have the the covers there on the side. Now, according to Toyota service information, you can replace an entire stack. You can replace the entire high voltage battery junction block assembly, but not the individual contactors. And of course, any of the wire harnesses, the fuses that are individual, it looks like all of these are part of the battery itself. Any individual pieces can be serviced. So it's a pretty simple battery setup. Now I had a scan tool hooked to a Prius with this exact battery in it right here in my classroom, and in watching the high voltage battery data list, the battery state of charge with the engine off was at 41%, and then it went down to about 28%. So it went from 207 volts down to about 198 volts before the engine would cycle back on, the internal combustion engine, run MG1, the generator, and bring the state of charge from the 28% that it got down to back up to the 41%. So just sitting here, 41%. I can't go drive these, so I don't know if it goes any higher. I do know that there's a limited number of cycles that you can cycle a lithium-ion battery, depending on what chemistry of lithium-ion battery this is. I do not know which one it is. There are many different types, but they all have a limited number of times they can be cycled between fully charged and fully discharged. Most hybrid and electric vehicles keep the battery between 20% at the lowest and 80% state of charge at the highest. So it was interesting for me to see this one at 41%. I would like to maybe get some feedback from some of you that can drive it with the scan tool on and see how high does that state of charge get. Maybe when you're going down a road or down a mountain pass and there's a lot of regenerative braking going on, and how low does it get? At 28 as low as I saw, 41 is as high as I saw. We could read the 6 battery temperature sensors. We could read the low voltage battery. We could read the DC to DC converter, charging the low voltage battery. We could read the individual cell voltages and the calculated resistance, the internal resistance of each battery cell. So as poor connections and as batteries go bad over time, they will build up a higher internal resistance, which will limit the amount of current that can go through them. They're all in series with each other. And so eventually, if the internal resistance gets too high, it'll become out of balance. It'll have the wrong voltage on the battery and will eventually trigger a trouble code. Of course, there are 56 battery cells combined between these two, and there would be trouble codes for each individual one. So a whole bunch of data and a whole bunch of trouble codes available there. Okay, if you have a Prius Prime, you will have 5 of these battery stacks in the trunk area, and they will be aligned with the length of the car. So you will have 5 of these in a row, and there are 2 hybrid battery junction blocks, all kinds of cooling. It's an air-cooled battery also, so cooling ducts and voltage sensors and temperature sensors all over the place. Okay, so the Prius Prime has 351.5 volts, 5 battery stacks of 19 cells each, giving us 95 cells, lithium-ion battery cells, for a total of the 351.5 volts. Very interesting, and of course they are serviceable battery stacks as well. Okay, well, this has been a review of the 4th generation lithium-ion battery pack and a little bit of information on the nickel metal hydride battery and the Prius Prime battery. Thank you for watching.